Good afternoon, everyone. Myself, Raman from Raman High School, Warangal, Telangana. Here we both are going to explain the method which is to define HCF and LCM of two numbers by using quadratic.
Good morning, friends. Myself, M. Shashank Reddy from Raman High School, Warangal, Telangana. Now my friend is going to explain how to find HCF of two numbers using coordinate geometry.
Let us see what HCF, highest common factor. Take into numbers A and B and plot on the graph as shown here. Now draw line segments whose endpoints are O and A. Whose endpoints are O and A. Here you can see on the line segment OA there are some lattice points. Therefore, HCF of A and B is given as number of lattice points on the line segment is decreased by 1. Let's one example 6, 8. Plot this two coordinates on the graph as shown here and plot as A. Here we can see a line segment OA. On the line segment there are 3 lattice points. Therefore, HCF of 6, 8 is given as 3 minus 1 is equals to 2. Let us see for 9.12. Plot these 2 points on the graph as shown here. Here we can see a line segment OA. On the line segment there are 4 lattice points. Therefore, its HCF is 4 minus 1 is equals to 3. Let's see what LCM. Least common multiple. Take numbers A and B and plot on the graph as shown here and plot as A. And here we can see a line segment OA. On the line segment there are some lattice points. And also here we can see lattice point which is introduced as R. And here we construct a rectangle QRBO. In the rectangle there are some squares. Therefore, LCM of A and B is given as HCF of A and B into number of squares in this rectangle. Let's see one example 8.12. Plot these two coordinates on the graph as shown here as A4. Now draw line segment OA4. On the line segment there are 5 lattice points. Therefore, its HCF is 5 minus 1 is equal to 4. And also here we can see a rectangle QA1PO. In the rectangle there are 6 squares. Therefore, its LCM is 6 into 4 is equals to 24. Let's see another example 4, 7. Plot these two coordinates on the graph as shown here as A. Here you can see a lattice point. Here you can see there are 2 lattice points. Therefore, its HCF is 1. And also here you can see a rectangle QAPO. In the rectangle 28 squares. Therefore, LCM of 4 and 7 is given as 1 into 9 is equal to 28. Now, friend is going to do the working rule.
Now I am going to show you the working rule of HCF. Let us take the natural numbers and let the HCF be and mark them on this graph sheet. It is here and mark this point as A.
Don't touch it.
And mark it as A. Now draw a line segment whose endpoints are A and O. And we can see this line is passing through some lattice points. Now we all know that the equation of line segment OA is given here. I am going to substitute the known variables in this equation. So I got y is equal to b by a into x. I am marking this as equation 1. And let the HCF of a comma b is equal to k. Then we can write a is equal to k alpha and b is equal to k beta, where alpha comma beta are the coprimes. And I am going to substitute these two in the equation 1. So I got y is equal to beta by alpha into x. Y will be an integer if and only x is the multiple of alpha. So we can say that x is greater than or equal to 0 and less than or equal to a. And we know that a is equal to k alpha. So x is greater than or equal to 0 and less than or equal to k alpha. And there are k plus 1 number of multiples of alpha from 0 to k alpha. They are alpha comma 2 alpha comma so on k alpha. And then we know that x is equal to 0 comma alpha comma so on k alpha and y is equal to 0 comma beta comma so on k beta. And we can see on this line segment there are some lattice points like 0 comma 0, alpha comma beta and so on k alpha comma k beta. These are k plus 1. So number of lattice points is equal to k plus 1. Then k is equal to number of lattice points minus 1. We assume that k is the GCD of a comma b. So GCD of a comma b is equal to number of lattice points minus 1. This is what my friend has explained you previously. And I am going to explain you the generalization for LCM. Let us take two natural numbers a comma b and let their HCF be k. Then a is equal to k alpha and b is equal to k beta. Here also alpha comma beta are the coprimes. Then LCM of a comma b is equal to LCM of k alpha comma k beta. Here k is the common factor. So LCM of a comma b is equal to k into LCM of alpha comma beta. Here I said you alpha comma beta are the coprimes. So LCM of a comma b is equal to LCM of k into alpha beta, where k is the HCF of a comma b and alpha beta are the number of square units present in this rectangle.
Go back. Don't touch it. If you go
And the number alpha beta are the number of rectangles number of square units present in this rectangle. So LCM of a comma b is equal to GCD of a comma b into number of square units present in this rectangle. This is what my friend has explained you. Thank you.